Hello everyone and welcome again to the SQL course. I hope you've enjoyed the exercises that I've prepared for you in the past section. Now here, in this part of the course, we are going to deal with data types, a new concept that I'm going to introduce here and that we are going to explore with more detail in this section. As you might have noticed in the past section of the course, we've worked with different types of data. So we've worked with numerical data, we've worked with text data such as names. Remember, for example, the columns where we've used the concat function to join the actor first name with the actor last name. Those are text columns. And the data types that each column contains also has impact of how the functions that we are going to apply are going to work on these data types. For example, if we want to make a square root of some number, it doesn't make sense to apply a square root to the letters ABC. So there might be some way for us to differentiate between these types of data that compose a full table. And as we've seen then, different columns might have different types of data. That's what we are going to explore here. We are going to work again with the SQL database. I'm not going to introduce many different databases in this course because I think that that would be an extra layer of complexity that is not needed. We already know the structure for the SQL database. We already know the structure, actor, movies, and etc. So we'll reserve different tables for the practical exercises. During the code along lectures that we are having here, we are going to explore this database, the SQL one. Okay. So here in SQL, don't forget connect to your local, and then we can start then to do our queries in the SQL database. If you don't have it loaded on the environment that you are working on, don't forget to recreate it using the scripts that I've also gave you in the course materials. So the query that we are going to follow is this data types numeric one, and you'll see this in the course materials. You'll have there in the second section. Here, in this case, in the 3 data types, second section, of course, with content regarding SQL. So if you go here to 3 data types, you'll see here the different scripts that we are going to use in this section. Let's go and code along to understand how this works. Okay, so first command that we will learn in this section is the describe command. So the describe command gives you more detail on the structure of a table that you want to analyze. So if you have a table and it contains different information about the columns, also called metadata or whatever how you want to spell it, but that's also information about the columns themselves, such as the data type, such as the size and other properties. You can access it with the describe clause. Let's see it. I'm going to pass sequila.film in this describe, and then I'm going to execute this query. And notice now the output is a table, but is a table with this metadata regarding the table itself. So for example, we have here film ID small int 5 as a type. So the 5 here, this is just when it's with numerics, it's just for a question of display width. Don't worry about this number right now. It sometimes seems a bit confusing. So don't worry as a beginner about this number. We'll probably explore it down the line in the course. What's more important is that you understand that this is a numeric column, okay? Because we have small int for small integer. Now, one big confusion because of this number right here is that the small int is that you look at this and you say that this will have 5 digits at maximum. That's not true. This number doesn't mean that. So the small int is actually a fixed range of numbers that you already have for numeric types. It goes from a certain amount until another certain amount, and what defines this small int is the number of bits it can occupy in memory in the computer. So what means is that now we are having a number in this column, and this column has this type small integer. And let's check what's the range for small integer. So I'm here on MySQL documentation. I'll leave this in the resources as well. But as you can see, if we are here on the small int, this takes 2 bytes, and then you know that we have at most the maximum value that we can have on that column is 32,767 if the column is signed. That means the column can have negative values. So as you can see here, we have here another characteristic, which is the unsigned one. This means that there can be negative values for this column. Okay, there can be -1, -2, -3. Those values don't fit in this column right here. Now notice this is a film ID, so it makes sense. Doesn't make sense to have an identification of the film or the ID of the movie as -2 or -3. That doesn't make much sense. That's why I have this extra characteristic here, unsigned, for our small integer. A small int means that we can only go, and if I go here, until the 65,535 ID, or in this case, there can be a movie with ID equals to 65,536. That can't exist because small int doesn't support it. If we need that, we need to go to the medium int, which is the other type, data type, right next to small int that takes a larger portion. What's the trade-off? Basically, you occupy more memory into space. Each number that you save will take more 1 byte instead of the small int. That's why, particularly for management of resources, it's important to set the minimum appropriate level or the minimum appropriate data type in terms of the integers. Notice that these are all integer numbers. That will take up less space, but will also not ruin your database. If you are expecting to have numbers as big, for example, as these ones, around more than 200 billion, well, in that case, makes sense to use the int, although it will take more space. Okay, so this is always a trade-off between what type of numeric type we use, in this case between tiny int and big int, and knowing that if we want to allow a larger number or a larger range of numbers in that column, we need to occupy more space in memory. So there's always a trade-off here. In our Sequila database, we only need the film ID. We only have 1,000 movies. We are not expecting to add more movies. So we can use, of course, small int, because the tiny int only goes until the 255 when it is unsigned. In that case, it wouldn't match what we need for our Sequila database. That's why we have small int. Okay. So I hope this was clear between the types of integer columns or data types in terms of integer columns that we can have, starting in tiny int, small int, medium int, and big int. And as we increment, we'll allow more numbers to be stored in there. In this case, it's not more rows, okay? Don't confuse it. It's the number itself that can be larger. It can be bigger in this case, because we can go for larger numbers. At the expense of that, we'll also have more storage. Each row that we have with data will take up more space using another data type that also allows for larger numbers. This is probably a bit confusing when you start to work with SQL. Don't worry, we'll see more examples in subsequent lectures. Just know this property also unsigned. When you have unsigned, you won't allow negative values in your column. That means that then your range, instead of your range of numbers, moves from the negative value. In this case, for example, the tiny int moves from the less 128 to the 0, allowing more space for this tiny int. Okay, returning here, what we have: film ID, small integer, and then it's an unsigned integer. That means no negative values. Also notice we have here key, primary key. This means that is the key of this column. This is the identifier of each row of this table. This will be important for when we combine tables using joins. Must be unique. Okay. Then we have auto increment. We'll also explore this when we are creating our own tables, so I'm not going to go too deep into it right now. And then we have, for example, another tiny int, as you can see here, language ID. We have tiny int unsigned. Again, this 3 is just for display purposes, okay? Nothing regarding what's the size of the column that we have inside, okay? And what are the values that the column can store? No, that is defined with the tiny int itself. We have here tiny ints. Notice that tiny int then only goes until 128 if it's a signed column. If it's unsigned, goes to the 255. Again, if you have a number 300, you can't put it in this tiny int. I think it will have a null value, or it will have an error when you try to insert those types of values, not recalling right now. And then we have here another small int for the length of the movie. Makes sense to be a small int, because I think that if this is in minutes, the maximum minutes that the movie can go, let's go here again to our reference, is 65,000 because it's unsigned. So a movie can only go to 65,535 minutes. I don't think there's a movie that's longer than that. If it is, then it's probably a really long movie. So it's a good data type to put, because if you can put, of course, medium int, but you will take 1 byte more for something that's highly unlikely, if not impossible. Okay, so we have here small ints. Let me see if we have here another thing that might be meaningful for these integer columns. I guess not. So let's just explore something. Now with integer columns, or with numeric columns that we'll explore in the next lecture, we can do mathematical calculations. We can apply any mathematical formula that we know to these types of columns. An example, I'm going to go here, mathematical calculations. And of course, this is enabled because of the property of mathematical numbers, and we have them stored as numbers in this column. So if I go for select as an example, film ID, the original one, or the length to make more sense. So length, and the length times 4 from the sequila.film, and I run this code. What we'll have is then the original data, 86, the original data for each movie. For example, there's a movie here that has 86 minutes, and the multiplication 86 times 4. And if I want to do this, for example, here, I can also apply some functions such as the logarithm. I think that the logarithm is also enabled for this column. As you can see, we have a number, so 86, and the mathematical calculation over that number. This is enabled because this is a numeric column, numeric data type. If I try to do this, for example, with the title, select title, let me just recall what's the title of the movie. It doesn't make sense to apply a logarithm to the title of the movie, right? So if I go to log title and try this on a non-numeric column, I'll have a null. Null means no information at all. It just means that SQL can't do this calculation by itself. It's impossible to do this calculation because you can't apply a logarithm to a character column. It doesn't make any sense. And how does SQL know that it can't apply this calculation, the log, to this column? It's because of the data type, because it's a non-numeric data type. Okay, so if you want to store numbers, something that you want to calculate, you use a numeric data type. Numeric data types are also common for identifiers, IDs, primary keys that you are creating on the table and that identify a single row. Because also, if you don't want to store pure text, then by default use the numeric data type because it takes much less space than a text column. Okay, that's important. And it makes your table much more efficient. Okay, so let's recap a bit on integers. We have 5 data types, and there they are: tiny int, small int, medium int, and big int. So these are numbers that we can store, but these numbers are also integer numbers. So you might be thinking, well, where are the decimal numbers? How can we store them? That's what we are going to see in the next lecture, and see another subtype of data types, which is the decimal and float data types. So that's what we will explore in the next lecture.